Alright, I'm recording now. Alright, so I wanted to make a video about this redstone circuit, this sequencer. Basically, it's a way to control delay on the off switch independently from on the on switch. And this is useful when you want to make designs that where things are happening in sequence, where you have some kind of action happening, and then you have an action happening after that, and then you have something happening after that, and then you want to control like a reverse order sequence on the off switch. So, like for example, if you wanted to make, make like two pistons, and you want to make their delay occur something like, I don't know, you want one piston to happen with a certain delay after the next one. So you just make a simple circuit like that. That makes it, there's a delay between these. But when you turn it off, the delay is happening in the same order. It's this first one that's going up. The first one goes up, and then this first one also goes down on the off switch. But what we want to happen is for the other one to go down on the off switch. We want the reverse order delay. So basically what you have to do is you have to create like a separate path of delay on the off. And the way that you do this is we're going to make this one now be the off path. So these are going to get changed direction. And then you're going to have something like that, and then this is going to be the this is not an on path, but I'm going to do this. And then that, and then you have that, I believe that should work. Right? Yeah. So now if you put a switch down here and switch it, yeah. So we have the same delay, this one gone off first, but now what should happen is that that far one should go down first on the off. See, that one goes down first, and now this one goes down. So we've reversed the order of delay on this circuit. And these delays are kind of long. I'm just kind of doing it just to show that delay is like the path that's happening is a separate path on the on and the off. And you can see when I turn it on that the path goes through this really fast, and then it goes, and then it goes through here, and then that's the delay on, and then the off is through a separate path. Or actually, it's more like the off collects. It's like it collects down here, and then on the off, this just kind of stays here. It's almost like the right here functions almost like a capacitor. Like when you turn it on, energy collects in these two, and then when you turn it off, it still stores and stays there until, I think that's kind of a way of thinking about it. It like stores there. Until the off switch gets. It's kind of a hard thing to explain. It's sort of like I understand it intuitively, but it's a hard thing to kind of convey. But anyway, I also wanted to show why this idea is useful, and it can actually happen too if you do it a lot. Like I think it'll just keep sequencing like that. Or maybe not. Uh-oh. Yeah. Okay. So, yeah. Here's another. It's basically the same thing, but it's set up with 3. So it's a sequence of 3. So now it's this one, that one in sequence. Then the reverse sequence should happen. It's basically stackable. So you're putting like 2 of them together. So that one, then the third one, and then in the off switch, the last one should go down, and then the middle one, and then the last one, first one. And this kind of design is really useful. I originally started trying to figure out how to do this when I was trying to build a loot pusher for a XP farm that I have, but I wanted the ground to kind of come down. So I built this big, let's see what I use. Let's see what's going on. So basically what's happening, oh no, this is the wrong, okay. Yeah, so what's happening is like I had, you imagine this is the bottom of a XP farm and I have a bunch of monsters falling right on these 4 blocks right here, and these are on the up right here. This is basically the I guess it's the off position, but because it's on an inverter over there, it's on because the pistons have to pull up. So when you flip the switch, I want the pistons to drop down, and then I want these 2 pistons to push each other out so that the loot gets pushed to like right over here. But it's basically 3 things happening because you have these pistons down here have to go down first, then this piston right here has to push these pistons, and then the pistons that will be right here have to push after. So it's actually a 3 thing. So when I flip it on, you get a good view. Those go down, that gets pushed out, and that gets pushed out. And then on the off switch, I need that to happen in reverse. I need these 2 pistons to come back first, and then I need finally the floor to come back up. Okay, so it's working. So basically this whole circuit is working. There's a basic delay here, and this is basically separating the floor pistons from these other 2 piston circuit. But because this floor piston is on the on switch first and these ones on the off, I need to invert it. So there's an inverter right here that's making these be off. That's making this whole circuit actually here be off while these ones are on. This other on switch over there goes underneath and just powers all the pistons that are underneath there on. So those are always in the on position. And when you flip it, it goes delay through the inverter. Then once it goes through the inverter, it gets split into 2, and it's basically just 2 of the same sequencer circuits that are happening in parallel, actually. I could make this simpler. I could just power, I only really need 1 of these sequencers to do both, but I don't know why I need 2. Maybe just for symmetry or something. But, yeah. The delay is like extremely long. I tend to like to put long delays on things just so I can get a sense of where the path of everything is going. And this pivot right here. Yeah, so these 2 sequencers up here are basically separating the delay between these 2 pistons, because these 2 pistons need to fire separately, because one of these is, now they're both sticky, but a sticky piston won't push another piston that's open. So it has to, the back one has to fire first while it's still closed, and then once that's open, then those ones can fire. So those have to happen in that sequence. Push, push. Okay, anyway, that's my whole thingy.